Assalamualaikum and a very good day to everyone. I'm Dr. Afika. I will be covering the topic for tools and machineries for this subject. So I'm sorry I'm not available last week. So in this lecture video, we will look at the topic on tools and machineries. This topic is quite fundamental in engineering because no matter which field you are in, engineers eventually needs to turn ideas into something physical, like the assignment you are doing now. You are turning the ideas into something physical. A good design is not just about drawing or calculation, but it is also about how the design can actually be built using real tools and machineries, where we will discuss today. So in this lecture we will go through the basic tools, machining, and also materials shaped into functional engineering component. In this lecture, we will first look at the role of the tools and also machineries in engineering and why these are important. And we will also cover basic workshop safety, because before using any tools, safety is always the first concern. Yeah. And after that, we will go through different types of engineering tools and introduce machining processes such as turning, milling, and also drilling. And finally, we will look at basic machining concepts and machine tools that are commonly used in the workshop. Okay. Although the topic in this lecture are a quite general engineering topic, but they are very relevant to biomedical engineering also. So biomedical engineering designed real devices that may come into contact with the human body, such as medical equipment, rehabilitation devices, and now we are making an orthotic orthotic device or assistive products. Okay, because of this, the way these components are fabricated, finished, and also assembled is extremely very important. Alright, therefore, understanding these tools and machining will help to ensure that biomedical devices are safe, accurate, and also reliable in real world application. Okay, by the end of this lecture, you should be able to recognize common engineering tools and machineries, and also understand the basic principle behind the machining processes. Okay, you should also be able to explain how mechanical parts are fabricated in workshop environment, and how this knowledge support good engineering design practice, especially when working on the design project later in this course. Okay, now let's us move into the first main part of this lecture, which is the role of tools and machineries in engineering. Okay, in this section we will focus on why engineers need to understand tools and machines, and how this element will support the entire engineering design manufacturing process. Okay, engineering design is often associated with the calculation, drawing, and also software tool. I believe that you have learned about the CAD CAM design during the second and third week, right? So while these are very important, the design alone does not complete the engineering, okay, process. The design must be something that can be actually manufactured. This means that engineers need to think about how a part will be produced, what material will be used, and which tool or machines are required. So if a design cannot be fabricated using available tools, then the design is not practical, no matter how good it look on the paper. Alright, so understanding tools and machineries will help engineers to create designs that are realistic, efficient, and also suitable for real world application. Alright, the fundamental skill across all engineering fields, knowledge of tools and machineries is not limited to only biomedical, to only mechanical engineering. So it is a fundamental skill across all engineering disciplines, including biomedical engineering. Yeah, and even if you are not, you do not operate machine yourself in the future career, you still need to understand how the components are made, because this will help you to communicate better with the technicians, maybe manufacturers or other engineers, and it also help you to design parts that consider manufacturing limitations such as the tolerance, surface finish, and also the behavior of the material, different material. And then the basic skill from an important foundation for any engineering design work. Okay. um we will look at now the precision and accuracy topic. These are very important, also important in engineering, especially when fabricating mechanical components. um so accuracy refers to, I believe that you have learned this during the prime secondary school, I believe, about accuracy and also precision. So accuracy refers to how close a measurement or dimension is to the required value. Meanwhile, precision refers to the how consistent that the measurement is when it is repeated. Okay, in machining, both are important. If a part is not accurate, it may not fit during assembly, and if it is not precise, the part may behave differently each time it is produced. For example, if a hole is drilled slightly off location or to the wrong size, the bolt may not be aligned properly. So this can lead to loose joint, uneven stress, or even mechanical failure. In biomedical engineering, such error can be more critical, as poor fit or sharp edges may cause discomfort or injury to the user, and this that is why engineers, we must use proper tools, correct machining parameter, and also accurate measurement technique to ensure both precision and accuracy in fabrication. So for those who are fabricating a conventional ankle foot orthosis in this subject, in your project, uh, try to imagine if you need to connect the fastener, the strap onto the ankle foot orthosis, right? And then because uh, because you want to attach this strap, you need to make a hole. Okay, so if you are making a very big hole, and then you need a like screw or like a rivet to attach the strap to the ankle foot orthosis. What if the hole is big, meaning that the strap will be loose, and then the bolt or the rivet will moving in this big hole. All right, so make sure you are using correct drill bits and correct step. Okay. All right, how this will connect to the design quality. So when engineers understand the precision and also accuracy, machining limitation, and it directly will improve the quality of their design. Like for example, and engineers who understand machining, they will avoid unnecessary tight tolerance that are difficult to achieve, or shapes that are difficult to fabricate. And instead, the design will consider practical dimension, proper clearance, and also realistic surface finishes. Alright, in biomedical engineering, design quality is especially important because uh, poorly manufactured component can also affect the device performance and then comfort and also safety. So by considering how parts are made, engineers can produce designs that are not only functional but also reliable and safe for the user. Okay, now let's move on to the next section, which will focus on the workshop safety essential. And before learning about the tools and machine in detail, it is important, like I mentioned just now, to understand the basic safety principle. Engineering workshop we know that it contains sharp tool, rotating machine, and also heat sources, which can be dangerous if it is used improperly. Okay, please observe carefully in the lab later, in the CPOE later, when you are working in the machining room. Okay, so learning and following safety procedures is an essential part of becoming a professional engineer. Okay, um a personal now we will look at the PPE, the personal protective equipment. Okay, this PPE is used to reduce the risk of injury when working in an engineering workshop. Alright, common PPE will include safety goggle to protect your eyes from flying chips, closed toe shoes to protect your feet from falling objects, and appropriate clothing that covers exposed skin. Long hair it should be tied back, and loose accessories should be removed, because it is very dangerous if you are wearing all this thing in the workshop. So wearing PPE may seem simple, but many workshop accidents occur because basic protective equipment is ignored. Alright, we have a lot of cases of all these workshop injury, and that is very scary. Okay, and now we will look at the general safety rules. In addition to PPE, there are general safety rules that must always be followed in the workshop. Machine should only be operated after proper instruction or training. Tools, workpieces must be properly secured, and work areas should be kept clean to avoid accident. And engineers should never rush machining operations, as rushing often leads to mistake. Okay, no need to be rushed in the workshop. Okay, and then following this rule will help to maintain a safe working environment and reduce the risk of injury, not for you and also but also for the other member in the lab. Okay. Okay, now we will look at the safety for rotating and cutting machine. So, rotating and cutting machine are among the most dangerous equipment in the workshop. Machines such as drills, milling machines, and lathe operates at a high speed. Okay, so loose clothing, jewelry, or untied hair can easily get caught and cause serious injury. So for this reason, it is important to wear fitted clothing and maintain a safe distance from this moving part. Alright. Always wait for the machine to come to a complete stop before making adjustment. Changing tool or removing the workpieces. Okay, never try to touch the chips or rotating part while the machine is still running, because it is very dangerous. Yeah. Alright, for the chemical and heat safety, some workshop processes involve the heat or chemical, such as hot surfaces, cutting fluids, adhesive, or heated material. So hot tools and material can cause burns if not if handled improperly. Okay, while chemical and coolants may cause skin irritation or produce fumes, so it is important to handle this material carefully. Make sure you follow instructions, and also ensure proper ventilation when working in this environment. And using the correct glove and handling tools properly will help to reduce this risk. Okay. Safety in the workshop is not only about preventing injuries, but also about the developing professional engineering habits. So accident can damage equipments, delay projects, and also put others at risk. So more importantly, unsafe practices can lead to serious injuries. By following safety rules consistently, we engineers can create a safer and more productive working environment. Okay, so good safety awareness reflect professionalism and also responsibility, which are very essential qualities for any engineers. Okay, now we will now move on to the next section, which focuses on the types of engineering tools Commonly used in the workshop, engineering tools can be grouped into several categories based on their function, such as measuring, cutting, shaping, assembling, and also machining. So, understanding these categories will help engineers select the correct tool for each task each task and work more efficiently. Alright, we have the measurement and marking tool. So measurement and marking tools, they are used to determine the dimension and mark reference point before any cutting or machining is done. Like for example, this tool can include ruler, measuring tape, okay, vernier calipers, and also the marking gauge. So accurate measurement is very critical because once material is removed, it cannot be replaced. An incorrect measurement at this stage often leads to an inaccurate part of material wastage. So for this reason, mm, measuring is usually the first and most important step in any fabrication process. And then we have cutting and shaping tools. These tools are used to remove materials and form basic shapes during fabrication, and these include tools such as the hacksaws, file, rasp, usually knives, and also chisel. So in many cases, these tools are used to prepare or refine workpiece before it goes to a machine tool. So proper use of cutting and shaping tools will help to improve accuracy, surface quality, and also overall fabrication efficiency. Okay, next we have the fastening and assembly tool. So this fastening and assembly tool are used to join. The function is to join different components together during assembly stage of the product. Okay, the common example will include a screwdriver, wrenches, spanners, Allen keys, and also riveting tool. So all this tool you will use for those who are in the conventional anchor for autosis fabrication. You will find all this thing in the workshop. And then this tool may seem simple, but they play a very important role in ensuring the parts are securely assembled and easy to maintain. So in engineering design, especially for the device that may require adjustment or repair, choosing the right fastening method and tool is essential for both functionality and also safety. And then we have power tools. These are the tools that use electrical or mechanical power to perform tasks more efficiently than the hand tools. For example, the handheld drill. Okay, we have the handheld drill in the lab, grinders, sanders, and also heat gun. Alright, power tools will allow engineers to work faster and achieve more consistent results. Like for example, you are using the normal screwdriver, but and it will take some time. If you are using the handheld drill, you can just fix like maybe 20 screw in 1 minute. Alright, but they are also require greater control and also awareness. Okay, because power tools operate at higher speeds, improper use can always lead to a material damage or also injury. And for this reason, engineers, we must understand that both their capabilities and also limitation before we use them. Okay, so heavy machinery, also known as machining tools, are precision machine used to fabricate accurate and repeatable mechanical part. For example, the drill press. Okay, if you enter the machining room, you will find a drill press. And then we have a milling machine you cannot find in our lab. They in mechanical lab, they have a milling machine and also lathe machine. So these machines are used to perform precise operations such as drilling hole, cutting flat surfaces, and also shaping cylindrical components. So, understanding how this machine work will help us engineers to design parts that can be fabricated accurately and safely in workshop environment. Okay. Alright, now we have the specialized tool. So, in addition to the general engineering tool, there are also specialized tools that depend on the engineering field and also application. For example, different industry may require tools for forming, finishing, or assembling materials in specific way. So in biomedical engineering, for example, these tools are often used to ensure smooth surfaces, accurate shaping, and safe contact with the human body. So understanding the tool requirement can vary depending on the field. Help engineers choose appropriate fabrication method for different application. Alright, we are entering. We will now move on to the next major part of this lecture, which is an introduction to machining. Machining, what is machining? It is a process used by engineers to shape material. Okay, shape material into functional parts with high accuracy. So in this section we will look at the machining, what machining is, why it is important, and how different machining processes are used to create engineering components. So this forms the foundation for understanding how mechanical parts are fabricated in an engineering workshop. We will go back on what is machining. Machining is a manufacturing process where material is removed from a solid piece to produce a specific shape and size. So in machining, cutting tools are used to remove small amounts of materials in controlled way. Well, this allows engineer to produce part which with accurate dimension and smooth surfaces, and machining is commonly used for materials such as metal, plastic, and also important process when high accuracy is required. So in simple term, machining is how engineers shape raw material into useful functional part. Okay, and the machining process usually follow a series of basic steps. First, the engineer will select the appropriate material and cutting tool, and then the workpiece is secured on the machine to prevent movement, and then the correct machine settings such as speed, the feed, and also selected are selected based on the material. And finally, the cutting operation is performed, followed by finishing step to improve surface quality and also remove sharp edges. So each step is very important to ensure that the final part will meet the required design specification. Okay, so each step in machining process plays a very important role in producing a good quality part. So if the workpiece is not secured properly, imagine what will happen. It may move during the cutting and cause inaccurate dimension. And if the wrong tool machine setting are used, okay, the surface finish may be poor, or maybe the tool may wear out quickly. So skipping finishing step can also leave sharp edges that are unsafe. So because of this, machining is not just about cutting material, but also following a proper process to achieve accuracy, safety, and also good performance of final part. And then the main purpose of machining is to produce components with accurate dimension, good surface quality, and proper function. And machining will allow engineers to control size, shape, and also finishing more precisely compared to many other manufacturing methods. Okay, so this is especially important when parts need to fit together, move smoothly, or carry loads. So in engineering practice, machining is commonly used to produce final parts, prototype for testing, and also components that require high accuracy and also reliability. Alright, we will now move on to the next part of the lecture, which introduce the different type of machining process. Okay, we have few machining process that we will discuss in this topic, which is turning, milling, grinding, drilling, broaching, boring, planing, reaming, facing, knurling, lapping, threading, and also taping. Okay, we will hope that you will use some of this type of machining process in your lab session later. And then machining is not just one single process. There are many different machining operation, and each one is used to create specific features such as flat surface, what machining process you want to use, round shape, hole, thread. So understanding this process will help you engineers to choose the correct method to fabricate any particular part. Okay, now we will first go to the first machining process, which is turning. What is turning? This is a process where is usually performed on the lathe machine. So in turning, the workpiece will rotate. The workpiece rotate while the cutting tool will stay in one position and removes material from the other surface. So this process is mainly used to produce round or cylindrical shapes. Okay, example of part made by turning include rods, shaft, pins, and also cylindrical connectors. So turning is commonly used when accurate diameter and smooth surface finish are required. And then we have the second one, milling. So milling is a machining process that uses a rotating cutting tool to remove material. So just now the workpiece rotate, but for milling the cutting tool rotate. Now the cutting tool rotates, while the workpiece is either stationary or moves slowly. So milling is very versatile, can be used to create flat surfaces, slots, pockets, and also complex shape. So milling is commonly used to produce mounting plates, brackets, and parts with flat or step surfaces. So there will be. I will continue the processing machining processes in the next video. So stay tuned. I will upload it. Maybe I will upload it on Tuesday. So this video is on Monday, and then the continuation of this lecture will be on Tuesday. I will upload the video on Tuesday. Okay.